Okay, now we're going to look at solving rational exponent equations. And so rational is just kind of a fancy word for fractions. So we're going to look at exponents that contain fractions. And so before we do that, though, we might want to review some of our properties of exponents. And so right here, here's the product rule. And so basically that is if you're multiplying like bases together, you actually add the exponents. So right here on example A, this is going to be x to the power of 5. So you actually add the powers. And the reason why is because if you think about this, x to the power of 3, well, that just means multiplying x upon itself 3 times. And x squared is just multiplying x upon itself 2 times. So how many times are we multiplying x together? Total of 5 times. So just be careful with that. So the product rule, common bases, you add the powers. Then we have the power rule. So that's if you have a power to a power, you actually multiply those. So this would become x to the power of 6. And if you think about this, it makes sense because if you're squaring something, that means it would be x cubed times x cubed. And then you can kind of refer back to the product rule that, oh, you're supposed to add the powers when you multiply like bases. And so you get x to the power of 6. So hopefully you recall those from a previous course. Now let's review radicals a little bit because actually these rational exponents, these fractions that we have as exponents, actually convert to radicals. And so we just kind of need to review this a little bit here. So note, if the index n is odd, then the following holds. So if you have an odd index, that's the value that's right there with your little check mark thing. Um, if it's odd, then you can go ahead and extract the negative from inside there and pull it to the outside. You don't have to do that, but it just kind of makes it a little bit easier so you can kind of focus on taking the root. And then also, if the index is even, the rule is a little different here. You're actually going to get a non-real or complex solution, and we've talked about that in some previous lessons. And so that applies not just to square roots, but fourth roots, sixth roots, and so on. So we're going to go ahead and evaluate these over here. So let's see. Before I do that, though, I'm going to go ahead. We're going to look at some common ones that we're going to see, some common values we'll see. So 2 squared, well, that's just 4. And then if you multiply by 2 again, that would be 8. And if you multiply by 2 again, 16. And then 32. And 64. And then 128. And I could keep going, but this is probably be about as high as we'll go for base 2. And then for base 3 right here, let's see, 3 squared is 9. And then if I multiply by 3 again, that would be 27. And if I multiply by 3 again, that would be 81. And then if I multiply by 3 again, let's see, that would be 243. And so for the most part, we won't get too crazy with our numbers, but sometimes on the homework problems, it's kind of random. And so you might get one of these larger numbers, but hopefully we'll stay in the double digit range. So let's go ahead and look at this. So what's going on here is we're asked to take the fourth root of 16. And so once again, we've kind of already discussed some of this in some previous lessons. But basically what you're trying to figure out is what, when raised to the power of 4, equals 16? What, when you raise it to the power of 4, would equal 16? And that would be 2 right here. You can see 2 to the power of 4 equals 16. So the answer to this is 2. Another way you can kind of look at this is you could replace the 16 with a 2 to the power of 4. And so when you're taking the fourth root, basically what's happening here is these two operations are going to cancel each other out, and we're going to end up with that 2. And you have to be a little careful with that when it comes to your signs, like if you're dealing with negative values or anything like that. Um, and so, for example, on C down here, what I would do is I would pull that negative out before I proceed to simplify to take the root. And so, anyways, let's do B first, though. So if you look here, so the fifth root of 32. So once again, you're trying to figure out what, when raised to the power of 5, would equal 32. That's essentially what that's asking you. And so if you look over here, once again, the answer is going to be 2. So a lot of these, our answers are going to be 2, 3, 4, stuff like that. The answers are not going to get too large on us. Now on C, as I was alluding to just a second ago, what I'm going to do, since I have an odd root, now if it was an even root, then we'd be dealing with a complex solution. But since it's an odd root, what I can do is I can just go ahead and pull that negative on the outside. It's basically like a -1, waiting to be multiplied into whatever I'm able to come up with here. And so -1 times the fifth root of 32. And well, I know what the fifth root of 32 is because we just did it. It's 2. So I end up with -1 times 2, which is -2. So that's going to be my answer for C. And then the last one, D, so the sixth root of 64, and once again, you can see that right here, so that's just going to be a 2 also. So all my answers were either 2 or -2. On your homework, you might get one that might be 3 or -3 or something like that, but like I said, we're going to try to, the numbers aren't going to get too crazy on us. Okay, so as I was saying before, these rational exponents can be converted into radical form. And so right here, if you have a base raised to a fractional exponent, you can actually convert it to where the denominator is going to be the root, and the numerator is going to be the power. Now, you can do it either way. You can put it on the outside, or you can actually put it inside. Most of the time, I like to put it on the outside. There's a few occasions that putting it on the inside could have its advantages, but most of the time we like to just kind of pop it on the outside so you can focus on taking the root first. So looking at this first one right here, we have 27 raised to the 1/3 power. So the denominator 3 is going to be my root. So I have to take the cube root of 27, and then I raise it to a power of 1, which really, power of 1 is not going to change anything. That's already understood if there is not a power listed. So really, I'm just focusing on the cube root of 27. And so if you look right here, up here, 3 to the power of 3 is 27. So that's what this is going to simplify into, is a 3. Because, let me show my work on this just to make sure we're clear. So 27 is the same thing as 3 cubed. And then, so we'll go ahead and do that, and then raise it to a power of 1, which, once again, that doesn't really affect anything. So that's going to cancel with this, and we're left with 3 to the power of 1, which is just 3. It's not necessary to include that power of 1. It's understood. Okay, let me give myself a little bit more room here. And so let's see, now we're looking at example B. So the denominator is 2, so I'm going to take the square root, and you can put the 2 there, but it's understood, so you don't actually have to put the index whenever it's a 2. And then afterwards we want to raise it to a power of 3. So see, the advantage here, if I put the 3 on the inside, I'm going to have to do 16 to the power of 3, and I really don't want to do that because the number is going to get pretty large. So now we're going to focus on this. So the square root of 16 is 4, and then we're going to cube that. So let's see, 4 times 4 times 4. Well, 4 times 4 is 16, and then times 4 again is 64. And so that's what that simplifies into right here. Okay, my next one, let's see, I've got 128 raised to the 3/7 power. So my denominator is 7. I'm going to take the 7th root of 128, and then we're going to raise that to a power of 3. All right, well, you can go look at your cheat sheet, but this is going to actually simplify into a 2. And the reason why is because 2 to the power of 7 equals 128. So that that 7th root right there is going to take care of the 7 power, to where I'm going to get 2 to the power of 3. And then 2 times 2 times 2 is 8. All right. So what we're going to do now is we're actually going to look at these in terms of equations. And so solve each rational exponent equation. So steps for solving a rational exponent equation in the form x to the power of m over n equals k. So first thing you want to do is isolate the expression with the rational exponent. Well, these first 3 examples, that's the case. They're all isolated. There's not anything being added or subtracted or multiplied to my base. So then If m is even, okay, so if m, the numerator, that's the numerator, if the numerator is even, then x is equal to plus or minus k, the value on the other side of the equal sign, raised to the reciprocal of what we originally had right there. So we had m over n, but now it's n over m. And I'll show you why that is in just a second. If m is odd, then we do not include the plus or minus. So once again, once we do a couple of examples here, you'll see why on one of them you have to put the plus or minus, and one of them you don't. So essentially what we're doing here, and I'm going to kind of show you the shortcut first and then kind of show you the more detailed way of looking at this. But what's going on here is you're going to raise both sides to the reciprocal here. So this is going to be to the 2/3, and this is going to be to the 2/3, right? And so if you notice the m value, my numerator, my original numerator is odd, so I don't have to worry about the plus or minus, okay? And so what happens here is power to a power, if you remember, we multiply. So you multiply 3 over 2 times 2 over 3. And so I end up with 6 over 6, which is really, it's just going to be a 1, right? 6 divided by 6 is 1, so x to the power of 1. And so now I just have to focus on simplifying the right side. Well, we just got done doing similar problems to this. What I have to do here is take the cube root of 8 and then square it. Well, the cube root of 8 is 2, and then 2 squared is 4. So that is my answer. That's what x equals. Now, I know I did that kind of quick. And like I said, that's kind of the shortcut. The idea is raise both sides to the reciprocal of the original rational exponent right here. And what's going on here is the property here is that if you multiply any fraction by its reciprocal, you just flip it, it's always going to equal 1. And so that's kind of the idea here. We're trying to solve for x. I want to know what x is. I don't want to know what x to the 3/2 power is. I want to know what just x. And so that's what we do here. Now, why on some of these I do plus and minus and some I don't? Well, we're going to look at C in a minute while we do that. But I'm going to break this problem down a little bit more that I just completed. So another way I could have done this problem, I'm going to go ahead and erase this so I can have room and kind of give you a more detailed explanation of what's going on here. So what we could do here is I could do this in pieces. I could actually go ahead and square both sides. So I'm going to go ahead and square both sides. And so what happens is this would become x to the power. Now remember, you multiply, so this would be 6 over 2 equals 8 to the power of 2, which is what, 64? And then this right here would reduce down to a 3, right? So I'd have x cubed equals 64. And now you're asking yourself, what to the power of 3 equals 64? Now what you could do is just cube root both sides, and so that's what I'm going to do. I'm going to cube root, and then I'm going to get x equals, well, it's going to be 4. And if you rewind the video a minute, you'll see that that's what we had as our answer. The answer was 4. And if you want to do it this way, that's fine. I don't have a problem with that. It doesn't take that much longer. Um, but if you watch any examples or anything like that, any videos, they're probably going to do it the way I did the first one, the first way. But let's go ahead and try another one. And once again, you could do this in pieces, but what we could do here is raise both sides to the reciprocal, which would be 4 over 5, and this one would be 4 over 5. And what this does is, when you multiply by a reciprocal, 5 over 4 times 4 over 5, it just turns into x. And that's really my goal for solving. I want to know what x is. And so then I'm left with this. So this is going to be the 5th root of 243. And then once I figure that out, I need to raise it to a power of 4. And if you look back at our little cheat sheet, you'll see that 3 to the power of 5 equals 243. So that means that this right here will just simplify into a 3. So I'm left with 3 to the power of 4. And then 3 to the power of 4 is going to be 81. And that's my answer. And like I said, if you want to take it in smaller pieces, you could. What you basically do is you would raise both sides to the denominator, just 4. But the problem with that, you can kind of see what the problem would be, is you'd have 243 to the power of 4. That's going to be a huge number. Now, you can use a calculator, so I guess it's not that big of a deal. But then once you get that huge number, then you're going to have to take the fifth root of that huge number. Once again, you'd have to use your calculator. So just from experience, I find it easier to do it this way. Just raise both sides to the reciprocal. And what you notice on the first two was I did not have to put the plus or minus. And the reason why is because I was taking the odd root of both sides. If you notice on my first two examples, I took an odd root. I took the third root, I took a fifth root, and so I don't have to account for there being a possible negative solution. So this is why I have to put the plus or minus whenever it's even. So let's look at C because we're going to see that on this one. So I'm going to raise both sides to the 3/2 power. Raise this side to the 3/2 power. So what you're going to see here, this turns into x, but then what you're going to notice is, oh, I'm taking the square root. Okay, and if you remember when we had problems like this, x squared equals 25, this is from a previous lesson, you would square root, and you had to put the plus or minus. Well, that's basically the same thing that's going on here. Technically, I'm taking the square root of both sides, so I have to put plus or minus the square root of 9, and then once I figure that out, we're going to raise it to a power of 3. Okay, so that's kind of what's going on if you remember from our previous lesson, because technically x could be 5 or -5 in my example up here. And so the same thing's going to happen here. You're going to get two possible solutions that satisfy this equation. So let's see, we're going to get x equals plus or minus the square root of 9 is 3. So we have plus or minus 3, and then we're going to cube the positive 3 and cube the negative 3. And in both cases, we'll get one that's positive and one that's negative. So if you really wanted to, you could kind of put the plus minus off to the side if you really wanted to, but it doesn't matter. You could do it here or you could have it like this. It doesn't really matter. It won't make a difference on our final solution. So let's see, positive 3 to the power of 3 is 27, and then negative 3 to the power of 3 is negative 27. So I get a positive and negative 27. So just to be clear, we have two solutions here. We have positive 27 and we have negative 27. And if you want to, you can plug it in and you can see that they will both work. All right, let's try another one that's pretty similar to what we just got done doing. So I'm going to raise both sides to the power of 3/4. Raise this side to the power of 3/4. And so on the left, that just simplifies into an x. And then on the right, oh, I'm taking the fourth root. It's an odd root. So I have to put the plus or minus, and then it's going to be the fourth root of 81, and then raised to a power of 3 once we simplify that. So looking at this, if you look at your little cheat sheet, you'll see that 3 to the power of 4 equals 81. So this is going to simplify into a plus or minus 3. So we're going to have x equals plus or minus 3 raised to the power of 3. And that's interesting. I think that was just our last answer. So we're going to end up with x equals plus or minus 3 to the power of 3 is 27, and then negative 3 to the power of 3 is negative 27. So coincidence, we actually got the same answer from the previous question, but as you can see, there were two different questions. Oops. But we ended up with the same solution. Just a coincidence. Okay, looking at our next one here. This time I have a quantity that's being raised to the power of 5 over 7, but I have to take care of that power first. So what I'm going to do here is I'm going to raise both sides to the reciprocal, which would be 7 over 5, and then raise this side to 7 over 5. And so that's going to basically, that's going to reduce into a 1 right there. So then I'm just left with x minus 3. I can just drop the parentheses. And then over here, let's see, it's an odd root, so I don't have to worry about the plus or minus. So I'm going to do the fifth root of 32, And then once I get that result, I'm going to have to raise it to a power of 7. Well, if you look on your cheat sheet, you'll see that 2 to the power of 5 equals 32. So that's going to simplify into a 2. And then we're going to have to take that 2 and raise it to a power of 7. And so if you look on your cheat sheet, I think it's 128, but let's double check. So, yep, 2 to the power of 7 is 128. So whenever you need to, just refer to that or use your calculator. So let's see, this is going to be x minus 3 equals 128. And then we'll go ahead and add 3 to both sides. And let's see, we're going to get x equals 131. And there we are. There's my solution. All right, I have one more slide, a couple more examples here. So once again, my example F is kind of like the last one. I got a little bit more going on inside those parentheses, but before I can address that, I have to get rid of this power, the 7/3. So I'm going to raise it to 3 over 7. So then I have to do the same thing over here, 3 over 7. And so then this will basically nullify each other. So then I'm just left with 3x plus 4 on the left side. And then on the right side, I'm going to have to take the 7th root of 128 and then raise that to a power of 3. And so we just got done dealing with 128. So we know that 2 to the power of 7 equals 128. And so that 7th root is going to simplify that into just that base 2 right there. So we're going to have 3x plus 4 equals, and so then this is going to reduce to a 2 to the power of 3. And 2 to the power of 3 is 8. So now we're going to be left with 3x plus 4 equals 8. And then now we're going to go ahead and finish solving for x. So we're going to subtract 4 from both sides. And now we're left with 3x equals 4. And then divide by 3. And we're left with x equals 4 over 3. Okay, just take it in small pieces and you should be okay. So just break it down. Now, what's going to be different about this next example is we have to isolate the 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 base that's being raised to the power. So that 20 and that 5,120 are not part of what's being raised to the power of 4 over 7. So we first need to kind of deal with those two numbers. So what we're going to do here is I'm going to start by adding 5,120 to both sides. And then we're going to divide both sides by 20. And I believe it's going to reduce down to 27. So x to the power of 4 over 7 equals, let me double check that though. In my head, I was off a decimal. I was actually, I don't know what I was thinking, but I was off a decimal place. So actually, this is going to reduce down to 256. Okay, so then now we're ready to raise both sides to the um, reciprocal, which is going to be 7 over 4 and 7 over 4. And then you should be like, oh, I'm taking an even root. This is even. This is even, so I'm going to have to put the plus or minus in a second. And so I'm just going to, I guess I'll keep working right here. So this is going to become x equals, and then this is going to be plus or minus the 4th root of 256, and then all raised to the power of 7. Now, on my little cheat sheet, we didn't do 4th roots. We didn't do, or I'm sorry, not 4th roots. I'm thinking of the base here. The base is probably going to be 4, I believe. And so what you could do is we could see, okay, let's see, 4 squared is 16, 4 to the power 3 is 64, and then if you multiply by 4 again, that's going to give us the 256 right there. So that's what this is going to reduce down to, is a plus or minus 4 right here. So I'm going to kind of swing up here, have a little bit more room. So let's see, x equals plus or minus 4, and then I still have to raise it to a power of 7. And so, yeah, this is where we're going to want to use the calculator. So let me grab my calculator. All right, so I got my calculator here. Let me turn it on. And so I'm going to have to do 4 to the power of 7. Yeah, it's going to be pretty big. So let's see, 16,384. So x equals 16,384. And then, yes, I need to put that plus or minus. So you have to look at it as being positive and negative. And so sometimes, probably on your homework, sometimes you can use that plus or minus symbol, but sometimes you're just going to have to write your answer twice, one positive and then one negative like that. And so there is my solution to that one. So I have two solutions. Either one would work if I were to plug it in for x right there. All right, last one. Now, what you're going to notice, this one's a little different. This one actually has rational exponents on two of the terms. So I have 2/3 and I have 1/3 and so on. And so this one's actually going to be done completely different from all the ones we've done so far. And so I include this one. I just really like this question. So what we have to do here is we're actually going to use factoring. Okay, we've done a lot of factoring in here. We haven't done any factoring that looks like this, but we're going to do it right here. And so the way that this works is what we're going to do is, and there's a couple different ways you can do this, and the most popular way is this thing called substitution. What we're going to do is, for a moment, we're going to let u equal x to the 1/3, right? We're going to let u equal x to the 1/3. Well, if I were to square both of these, if I were to square them, then that would mean that u squared is equal to, and then here you multiply, right? So this would become x to the 2/3, right? So what I'm going to do is basically for x to the 2/3 for a moment, I'm just going to replace it with u squared. And then over here, minus x to the 1/3 is actually just equal to u. So I'm going to replace that with a u. And then we're going to have minus 6 equals 0. And then what we're going to do is go ahead and factor this like we've done before. And this one's actually very easy because if you're looking for two numbers that multiply to give you -6, but add up to -1. And so that's going to be a -3 and a +2 right there. Okay. And then you can do it now or you can do it after the next step. What we need to do is go back and be like, oh, well, yeah, u is equal to x to the 1/3, and so we need to put that back in there. You can do it now, or if you want to, we can go ahead and finish this like you normally would by factoring. You would take each factor and set it equal to 0 and solve. So let's see, I'll add 3 to both sides. So u equals 3. And then over here, I have u equals -2. Now, this is where you have to be careful because a lot of times students will just stop at this point, but we're not done yet because those are not my answers because that's not what was originally there. What was originally there was x to the 2/3 and x to the 1/3, right? So u, right now we disguise the u value, but u is really x to the 1/3. And so we actually need to go ahead and put those back there. So this is going to be x to the 1/3 equals 3. And this is going to be x to the 1/3 equals -2. And then in order to solve this, you raise both sides to the reciprocal, which in this case, this is actually going to be a little bit easier. It's just going to be a 3. You're just going to cube both sides. So we're just going to cube both sides. And so that this is going to reduce to x equals, and then 3 to the power of 3 is 27. There's one of your solutions. And then -2 to the power of 3 is going to be a -8. -8 right there. And so that's our solution. So that one obviously was a little different than the previous ones we had done, but at the end it was kind of the same. You had to raise both sides to the reciprocal and kind of go from there, but it was a little bit easier. The harder part was this new thing called, we call it U substitution because you're using the letter U. And you could have probably factored it without doing U substitution, but at the same time, it's kind of good to experience that because we use that in other math courses, this type of substitution. Especially if you're going to go to calculus and stuff like that, you're going to be using this um, you're going to be using this method of U substitution. So, all right, well, that's it for this video. If you have any questions or concerns, just let me know.